Hello, in this video I'm going to make my most favorite of all projects, well, probably, and that is, of course, the Snail Races. I love this project. I'm going to make a Windows Form application because that makes drawing and having timers just a little bit easier than WPF. Also, the purpose of this activity is to get used to just creating class files that have properties, and it doesn't matter which user interface framework we use to accomplish that objective. So why not just go with the easier one? I am going to open up Visual Studio here, and I'm going to say create a new project. And I'm going to search for WinForms, and I want to make sure that I pick the C# WinForms.net framework. There we go, C# WinForms.net framework. And I'm going to click Next, and it will take me to the screen where I can name my project, and I'll say I want to call this thing the Snail Races. I'll just leave the other stuff the same, and then I'll click Create. And Visual Studio will sit here and it will spin away and it will create a project for me. Whee! There we go. All right. So there's our form, there's our properties. This is our kind of standard Visual Studio layout. You can see that we picked the right type of project. It has .cs there. So let me do the things, knock out the first couple of things I always do when I create a new project. I'm going to click on the form and I'm going to change the text from being Form 1. I'm going to call this Snail Races. There we go. So that's just a little bit more professional there. You know, it looks so lazy just leaving it as Form 1. And if you didn't have your toolbox there when you open Visual Studio, you can always get to that through the View menu. You can just go to the View menu and you go down here and you can select Toolbox, and the toolbox will pop up. All right, so what other things do we need to add to our form? Let's add a timer control. So in the filter window on the toolbox, I'm going to type timer, and you'll see that timer now shows up as one of the only option. And I'll just drag that onto my form. And over here now you can see I'm looking at the properties for that timer. It's disabled, which is okay, and we'll leave the interval set to 100. That's fine too. We'll just leave the default properties set. And now when I say properties, you're like, oh, right, properties. Yeah, he just did a 25-minute talk on properties. Properties are a proxy for a private variable. Yes, these things are properties like I just talked about in the previous slide deck. All right, so what else do we need on our form? Let's add a picture box because that's where we're going to do our drawing. We're going to use that as our canvas. If you are a Java programmer, you could think of this as a canvas object. Let's just throw it on there, kind of size it, you know, however we think we may need it. Well, we can kind of resize things a little bit here if we need to, and we will. And let me throw some buttons on here. So in my toolbox, let me type in the word button, and you can see it is now filtered out the buttons. And let me throw one down there. And I'm going to call this, I'm going to rename it, I'm going to call it Go. There, I'm going to change the text property on that. And let me put in another button here. I'll call it Reset. I don't really even know if I need 2 buttons. I guess we'll find out. Now, let's go add the resources for this project. And whether you're using WPF or using WinForms, it is the same. It is project, properties, resources, project, properties, resources, project, properties, resources. Just say that over and over again, pound on the desk while you say it, and it will stick in your brain. Project, properties, resources. There it is. Okay, now what do we do? There's a drop down here. We can say add existing file. So let's go out to where you've unzipped the resources for this project. And let's go find those. There we go. Now I'm going to hit Control-A to grab all of these and click Open. And you will see Visual Studio has created a folder for me called Resources and imported all those PNGs into my project. Awesome. All right. Let's go back to our form here. I'm going to click on the little tab for the form. And what I'm going to do is I'm going to set, you have to be very careful with this step because it's easy to get it wrong. Let's look in the properties for this picture box. There is an image property, which it can display, but there's also a background image property. So what we're going to do is we're going to set the background image property. And we're going to set it to that kind of oceany seascape. So I'm going to click on the little dots next to that, the background image, and I'm going to pick from my resources, I'm going to select background and click OK. And you can see now that my picture box was not sized properly. However, if I click on this little black arrow next to, or at the top right, notice that there's a size mode drop down, and let me say auto size, and let's see if does that do anything. Or maybe you can't auto size a background. All right, maybe that only works if it's the image property. So you know what I'm going to have to do? I'm just going to have to kind of wing it here, and all right, so we'll just kind of eyeball it. There we go. Whoops. Very nice. All right, so the key there is that this ocean picture, bikini bottom, whatever this thing is the background image. It is not the image property, because we are actually going to draw images on this picture box, and if that is not the background image, then our images may not show up on top of it and we won't see them. So it's very important that we have set the background image property here and not the image property. Now, the whole point of this thing is to make some snails race across the screen. So let's go make a class that represents a snail. And I could, I could say view code, and I could put the snail class in the same class as the form. But just to show you that you don't have to do that, let's right-click on the project here. So I right-clicked on my project, and you can see that there's an option here for add, and at the very bottom, class, or you could type Shift-Alt-C would do it for you. So you right-click on your project and you say add class, and that will add a new class file for you. It'll ask you what you want to call that file, and let's call it snail. Snail.cs. Click add. All right, so now Visual Studio has now created us a file where we can define a snail. So let's add, we're going to need some libraries here. We're going to need to be able to draw images. So let's import system.drawing. So that's going to allow us to work with images. And then let's think about what are the instance variables for a snail. What does a snail have? Like what does a snail have, and what does a snail know how to do? Well, let's say that a snail has an x coordinate and a y coordinate. So let's make an integer called x and an integer called y. Now, I have not said that these are public, private, or protected, so they are private by default. So no one, the outside world, cannot access these properties. And then maybe the snail has to have an image, right? The snail has to have a picture or an icon. That's an image object, and let's just call it image with lowercase. So these are all class variables. So a snail has an x and a y and an image, and then maybe in order to, when the snails run, they're all going to kind of run at different speeds. So let's give a snail a random number generator. I'm going to call it rand, and this is an object, so I have to allocate it using new. And so this is okay to do in C#. If this were C++, it probably wouldn't let you do that, and you'd have to create rand here, but then you'd have to you have to create it in the constructor. C# is a little bit more flexible. Okay, now let's create a constructor for our snail that sets, what do we want? Well, let's add a constructor to our snail class. So let's let's think about maybe when you create a snail, you give it, you know, a y coordinate and an image, and its x coordinate defaults to something else. So let's make a constructor. So if you just type CTOR and look, it says a code snippet for constructor. Note tab twice to insert CTOR snippet. Tab. Oh, look, it gave us a constructor for a snail. So when we make a snail, what does a snail need to know? Maybe we give it its y coordinate. And so there's going to be a problem here, and you'll see it in a second, and we'll have to figure out how to resolve it. And maybe it takes an image, img. So now what we have here is something called a name collision. This snail has a y variable, and we have a parameter called y. So how do we differentiate the y that belongs to the snail from the y that is being passed in as a parameter to this constructor? Well, we could, you know, give them different names. That would work too. Or we can use the keyword this. This dot y equals y. So every object has a this pointer, which allows you to specify the object's variables versus the parameters that are passed into functions. So y by itself will refer to the parameter, but if we want to explicitly refer to the object's properties, we can preface it with this. So this object's y equals the y parameter. And we have to do that because we have a name collision there. We don't have a name collision with the property or with this variable. So let's, we could, so now, yeah, let's set the private variable equal to the parameter there. Now let's say that we wanted to make a public property for the image. Let's see how that would work. Let's just type prop tab, and now we have to supply the type of our property, which is an image, and let's call it image. Now it turns out you can actually have a property and a type. They can have the same name. So now we can set this. Well, all right. Let's make this a set only property. There we go. And then what does the setter do? It'll set our private variable equal to whatever the right-hand side was, value. There we go. So we can't get the image, we can only set it. There we go. That works. And then what if we wanted a property to set the y coordinate of a snail? Or yeah, let's make a property for x. So when we reset the snail, right, we can put the x, the snail back at the start or something. So let's make a property, prop tab for x. X is an integer. We'll call it x. And maybe it's also a set. Now we'll make it a get and a set. All right, so it'll just be an alias or a proxy for x. So when we try to access our x property, what it'll do, it'll return x. And when we try to set x, it will set our private x variable equal to value, which is that C# keyword for the right-hand side of the equation. Okay, now do we really need to do all this? Not really, but so here's our snail has, these are all private variables, and we can interact with the x and the image variables using these public properties that we have specified. So notice that the properties are public. I mean, I guess you could have a protected property. I don't know. It doesn't really makes much more sense for properties to be public. All right, and then what does a snail also need to be able to do, right? A snail needs to be able to move. So let's make a public function, public void move. All right, and what is what's the move function going to do? It's going to move the snail over by a couple of pixels, right? So let's change the snail's x coordinate. Right now we can say x plus equals. All right, so how do we get a random number? We have a random number generator, right? We made one up here called rand.next. Oops. And let's say, I don't know, 0 to 5 or something. We can change it later if we have to. And, you know, if you wanted to put in comments or something for in the IntelliSense to find 3 slashes is how you do that. You know, and then you can put in your comment, moves the snail right by a random amount of pixels. There we go. All right. So, oh, and then what else does a snail need to be able to do? A snail needs to be able to draw itself. That's got to be public. Let's make a public draw function, public void draw. Now, this is interesting. The snail knows where it is, and it knows what its image is, but it doesn't have the canvas to draw itself on. That is called a graphics object. So a graphics object is like your JavaScript or your Java canvas. And let's just call it G. So, and then we'll put in our comments, 3 slashes, draws this snail on graphics object G. All right. So how do we draw ourselves? How does this snail draw itself on G? G dot draw image. There we go. Okay, so look at the different overloads. There's 30 overloads. So we can give it an image. I think we want to give it, there's a whole bunch of them, right? But the one we want is an image, an X, and a Y, right? The snail has an image, right? And it has an X, and it has a Y. There we go. That's all. So I think that's all we have for a snail. The snail we can move the snail around, we can reset the snail, and we can make the snail draw itself. Now let's go back to our form here. I'm going to click on the form, and we've got to kind of hook up the framework that's going to make our game kind of tick and draw itself. So how do we get this drawing to happen? What we need to do is trigger an event on this picture box that tells it it needs to redraw. So let's go to our picture box here, and let's go to the lightning bolt. So the lightning bolt's where we can hook into the events for that picture box. And what we want to do is come in here. We want to find the paint event, and let's just double click in this blank area next to the word paint. So I'm just going to double click in this blank area right here, down at the bottom right. And what will happen is Visual Studio will create a paint function for me. So when this function is called, the canvas will redraw itself, or the picture box will repaint itself. And we'll get to how to trigger that in a second. Now up here in our Form 1 class, let's go add some snails, because we created a class called Snail. So now we've defined a type, right? We can go make snails. Snail, and I'm going to call it Snail1 equals new snail. And what does a constructor for a snail take? It takes a y coordinate. I'm just going to make up a number, and I'll probably have to change it. And it takes an image. So how do I get the images? Was it properties dot resources dot, okay, look, I've got all my different snails. How about Rocky? We'll throw Rocky in there. And then let's make some other snails. Snail 2, snail 3. And I'll put like this snail at 150 and this snail at 200, and I'll change their images here. I forgot which snail is which. can I open these guys? I don't know. I'm gonna go look at the snails. C#, week 2, activities, snail resources. Okay, so we've got, so let's go to 2, 3, and 6. Let's go with them. No, 3 and 6. Let's go with 3 and snail 6. There we go. So now I've created 3 snail objects. They each have a different Y coordinate. They each have a different image. Awesome. All right, so in the paint function, what we now need to do is tell each one of these snails to draw. We're going to call the draw function for each of those snails. Now remember, the draw function for the snail requires us to pass it a graphics object, and I'm going to show you in a second where we get the graphics object. So let's say snail1 dot, oh look, there's our public draw function, and see our 3 slashes, now it shows up in the IntelliSense. Draw this snail on graphics object G. Oh boy, we just wrote that like 5 minutes ago. That's our text showing up in the IntelliSense. It's so exciting. Okay, great. Let's call our draw function, and let's see what it takes as a parameter. Notice it takes a graphics object G. Awesome. Where does this magical, mystical graphics object come from? Well, it's actually hiding in this structure right here. So as I said in the week 1 videos, this second parameter for the event handler contains information about the event. So a mouse event handler will have a second parameter that gives you like the coordinates of the mouse, right? And the paint event has a second parameter that gives you information about, the paint event. And the thing that, one of those things is the graphics object to which the paint event applies. So let's look in E here and see, oh look, there's a graphics object in there, the very first thing. And then let's take the, there you go. All right, so now our paint function will draw all 3 snails. Now, right now, this code is screaming at me saying, take all those snails and put them in a list and then loop through the list, and then you can have 1,000,000 snails. But then the brakes come on and we haven't gotten the lists and collections yet. So if your brain is screaming at you that this is just crying out for a list, I feel your pain. However, for the sake of reducing complexity and just focusing on classes, constructors, and properties, I am just making it this particular way and avoiding the complexity of bringing in collections. So let's run this and see if it actually works. So if I hit the play button, okay, there we go. You can see that our snails do show up, although the Y coordinates seem to be off a little bit. And maybe the snails are too big and I should have resized those using GIMP or something like that. But okay, so let's change the Y coordinates of the snails. No problem. So let me make this guy 50, I don't know, 150 and 100. Let's try that. Does that come out any better? Ooh, that actually came out great. Awesome. I mean, the images are left justified. I guess I can live with that. Otherwise, we could modify our draw function to subtract the width of the image. That would work, or we could scale them in GIMP. But I think we've got what we want going on here. Now we've got these buttons. Let's disable the reset button, because there's no point. That doesn't really make sense that it should be enabled when the race starts. So let me go to the form designer, and I'm going to click on that button, and there's an enabled property for that button, and I'm going to set that to false. So now that button should be grayed out. If I run this now, that button should be grayed out. Okay, you can see it's grayed out. All right, awesome. And then let me double click on the go button here. And now, okay, so now we can click on the go button, and when the go button is clicked, let's disable the go button so you can't click on it a second time, because that doesn't make sense. So let's say when they click on button 1, we'll disable button 1. Button 1 dot enabled equals false. All right, there we go. And then we need our timer tick event, right? So we added that timer to our form. Our timer is going to drive the drawing. So let's go back to our form. And down here on our timer, you see it at the bottom left, we have this timer. Double click on the timer. And Visual Studio will create a function that will get called whenever that timer ticks. So what do we want to do when the timer ticks? We want to move the snails and we want to redraw. So how do we move the snails? Well, we made a public function called move. So let's say snail1.move, snail2.move, snail3.move. Now, again, if we had put all these guys in a list, we wouldn't need to do that. We could just say for each snail in list, whatever, then s.move, and life would be real simple. But again, reducing complexity. Now, how do we trigger the redraw? Well, that is something we can, there's two ways to do this. We can either send an invalidate message to the picture box, or we can tell it to refresh itself. And I think the way I'll do this here is to just tell it that it has been invalidated. So when you move one window around over top of another window, the window on the bottom gets invalidate messages telling it it's been disturbed and it needs to repaint itself. So how do we trigger the paint message on that picture box? We tell it it's been invalidated. So we say picture box 1 dot invalidate. There you go. So what this will do is this will queue up a paint message that the picture box 1 will eventually receive. It doesn't get it right away. If this isn't notice we're not calling paint directly, right? We're not passing it a sender and a paint event. So we are calling invalidate, which will queue up a paint message that this control will eventually receive. If you need it to occur immediately, like right now, refresh is the better way to go. You can say picture box 1.refresh. That will call this like right away. But in our context, it doesn't really matter. So let's run this and just see if it works. So if I click go, oh, you know what? And no, it's not going to work because what I need to do is start the timer going. So when we click button 1, let's start timer 1 going here. Timer 1 dot enabled equals true. Or we could say timer 1 dot start. They're both equivalent. So let me run that. And now if I click on go, you can see that button's not active. Oh, look, our snails are racing. What's going on here, though? They're all in lockstep. It's uncanny. Well, I can tell you what's going on here, and that it's C# random number generation is very, very poorly implemented. And what's happening is random numbers are very closely tied to the clock, and because we're telling the snails to update at the same time, they're all getting the same random number. Actually, well, let's look at our snail class. Our snails all have random number generators. And the seed for that random number generator is based on the clock, but because our snails are all created at almost exactly the same instant, those random number generators are getting the same seed. So the sequence of pseudo-random numbers they produce is identical. So how do we fix that? Well, it's actually surprisingly easy. Right now, all the snails have a random number generator. If there's 12 snails, there's 12 random number generators. Do they need 12 random number generators? Like, well, no, right? They could all share the same one, right? That would work fine. How do I make them all share the same one? Well, I can make this random number generator static. Static means there is one shared copy for all instances of the snail class. If there's a million snails, they are all sharing the same random number generator. So static means there is one shared copy. It doesn't mean you can't change it. That's what const is. Static means there is one shared copy. In fact, in VB, static means shared. If you want something to be static, you write shared. A much better definition. So now let's run this and see what happens. Now if I could go, oh yeah, look at that. They're all sharing that same random number generator now, and now each snail is getting the next number in the sequence. Okay, so now our snails are racing. Oh, yes, ladies and gentlemen, place your bets. So now all we're missing is some code to see if they win, right? We got to check to see if they're, who crosses the finish line first, because right now they're just going to run off the edge and never come back. And that's all she wrote. Okay, so we need to put in some code to check to see who won. So how can we put in some code here that checks for a win? Let's go back to our forms code. And let's go to that timer tick event. So after we do the draw, let's check to see if any of the snails have crossed the finish line. And maybe we'll call our picture box is like 800 pixels wide. Maybe we'll call the finish line 750 pixels. And this won't be like a photo perfect finish. Maybe we'll just check to see, okay, if snail 1's greater than the finish line, we'll call that, we'll say that snail 1. Let me go back to the top here. Let's make a constant variable for this. Let's make a, we could say, int finish line equals 750. But if this thing is not meant to be changed, let's mark it const. Oh, and I got to click stop there, otherwise it's going to give me some errors. So let's mark that const, and then let me come down here, and we'll say maybe if snail 1 dot x is greater than the finish line. Else if tab snail 2 is greater than the finish line. So I guess it is possible that some snail could get gypped under this circumstance. But this might be a scenario where, you have the snails in a list, you sort the list, and then you check to see if one snail is greater than the finish line, and if there isn't a tie, then one snail wins. Otherwise, you have to let it go another thing, or you say there's a tie. So all we're going to do here is just check to see, did snail 1 cross the finish line, did snail 2? And we're going to assume that they're not both going to cross the finish line at the same time. So let me pop up, well, we could do a bunch of things, right? We could pop up a message box dot show, snail 1, 1. And otherwise snail 2. And maybe we give them names like, I think snail 1 was Rocky, right? I don't know what their name. And then we had like Snelly. I think that was one of the snails. And I don't know what Slimy or something. What do you call snails? Snelly 1. And anytime a snail wins, right, we have to shut off the timer. So let's say timer 1 dot timer 1 dot stop. Timer 3 dot stop. There we go. All right. Now, I'm not quite sure what I was thinking here, putting in timer 1, 2, and 3 dot stop. There's only one timer. I'll just tell the timer to stop And then also remember that reset button. Let's enable the reset button. So that was button 2. Button 2.enable equals true. There we go. And again, this is not the most elegant code, right? So if any snail crosses the finish line, print out that snail 1, stop the timer, and enable the reset button. Okay, and then did we actually implement the reset button? We did not. So let's go back to our form. Let's double click on the reset button. And when we click on the reset button, what do we need to do? Well, we'll disable the reset button because we just resetted. Button 2.enabled equals false. And we need to reset all of the snails. Now, how do we do that? Let's think. Do we have a reset function in the snails? No, we can, but we have that X property, right? We can set their X property back to, and what did we initially create it at? We put them at, well, let's look at our snail. What do we set the X to originally? Maybe I think we just have it as 0. So let's go back to the form class, and I'll just set every snail's X coordinate back to 0. So let's try it out and see if it works. Now let me think here. There could be a time bomb working here. There is a time bomb working here. Whatever I just showed you, don't do this. Message boxes and timers are a dangerous combination. You want to shut off the timer before you pop up the message box. Otherwise, you will just keep popping up message boxes. All right, that's, I think, what we want. Let's give this a go. So stop the timer, then pop up the message box. Otherwise, we pop up the message box, but the game keeps going, and what does it do? It just pops up more message boxes. So let's run this and see if it works. Yeah, no, that's Snelly down at the bottom. Okay, let's click go. There go our snails. Yeehaw! I'm just gonna pause the recording here and wait for them to get to the finish line. All right, we're about to get to the finish line here. Somebody better win soon. Snelly won. Okay, so I think what we need to do is move our finish line back maybe to the left 100 pixels, and let's click OK. And you can see now that the reset button is enabled. Let's click reset. Oh, you know what? So why doesn't that work? Well, the snails actually did get reset, but we didn't redraw. So let's go to down here, and we can back to our code where we check for wins, and we can say picture box 1 dot invalidate. What we need to do is trigger the repaint. And again, this is not the cleanest code because, you know, we're just sort of imposing the arbitrary restriction that we're not allowed to use collections at this point. So, all right, I'm going to let these guys run here, pause the recording. All right, let's see what happens now. And Snelly won. Okay, so I bumped the finish line 50 pixels to the left. I guess maybe I'll bump it another 50 pixels to the left. Let me click OK. Reset. Why are we still not seeing the snails put back at the start? So let's go investigate that. Oh, you know what? I am just really silly here. I put the invalidate in the wrong place. So I was putting the invalidate in here for the snails. We don't need this. We don't need this. We'll just, take this. And what we need to do is put this in the code where we reset the game, where we reset the snails. So if I stop this, run this, and I'll click go, and I have my finish line now set to 650 instead of 800 or 750, which is I think what it was before. And let me click go, pause the recording. All right, so Rocky is not doing so hot this round. Snelly won. Seems like Snelly always wins. Okay, so now I click OK, reset, and you can see the snails got put back at the beginning. All right, so now I think we've got, we've done a good job here creating, a class that has some private variables and a constructor, and then it has some public properties that restrict access to those private variables. So that's the purpose of these properties, is that they seem like they're variables, or we interact with them like they're variables, but they're really not. They're actually getters and setters that can perform stuff behind the scenes, like validation, and you change one property and it changes another property. So there's an example of that. I mean, it's kind of fun. Oh, what else? One last thing. I think when you make a form app, you should put a menu strip on it. Let me take a menu strip, put it up here. That's why I gave myself just a little bit of space. And I'm going to type in file, exit. Oh, now here's a cool trick. If I type ampersand exit, I think this will work. See how that turns into an X. And then actually under the file, what if I put in, oops, I don't know if it's going to work. I probably missed my chance. Oh, Alt, what if I put in an ampersand before that? So now I should be able to type Alt FX, right? So that underline, it becomes the keyboard shortcut. So that's the ampersand. That's what it does for you. And then let me click on exit here, and I'll say application dot, is it application dot quit or application dot exit? Application dot exit. There you go. So now I have an exit menu. And what else? File. Let me put an ampersand help, and then ampersand about, and I'm going to double click on about, and I'm going to say message box dot show, and in the text I will put, oh, if you get that blocky cursor like that, that's because your insert is on. That drives people nuts, and nobody ever told you that, but I know that because the original 1980 IBM PC was like that. And guess what? I used to write my papers on that, and that's where I learned about that insert thing. And that drives people nuts. They don't know that. So let's say, by Evan Wright, semicolon, and let's run it now and just see if the menus work. So menus work just like buttons, right? You just double click on it, and I don't see the ampersands though. Let me try Alt H A, right? Oh, look, it popped up the about. Okay, Alt F X, and it quit. Cool. All right, so now we've got menus in there. All right, so that is it. That's the Snail Races. I love this project, right? I mean, we've really created our own little 2D game engine here using Windows forms. And I don't know, it's just a lot of fun. So I hope you enjoyed that project as much as I did. Obviously, I will post this code so you can go through it at some point. But I'd say make sure that you understand, how to write a class, how to write a constructor, that you can have multiple constructors that are overloaded, how to write, functions, and how to write properties. What does it mean for something to be static versus something to be an instance variable? I think you're in good shape. If you have any questions about this, just email me. I'll be happy to explain it to you.